Music today is just invisible code floating in server farms. Zeros and ones. Yet a 70-year-old relic survives the digital purge almost unchanged, the vinyl record. It is a physical anomaly in a virtual world. While streaming platforms update algorithms daily, the machinery here has barely shifted since the mid-20th century. Inside the plant, sound waves stop being data, they become structure. Black pellets melt into a malleable puck and the hydraulic press descends. 100 tons of force. In a single violent motion, millions of microscopic grooves are imprinted into the surface. The invisible becomes tangible. To see how a digital file transforms into a playable disc, the manufacturing line starts its cycle. The machinery awakens for a singular purpose: to freeze sound into matter. Unlike digital files composed of zeros and ones, a vinyl record is purely mechanical. A diamond stylus navigates a spiral groove 50 times smaller than a fingerprint ridge. The walls of this tunnel are not smooth. They are textured with microscopic waves. As the disc spins, the needle physically vibrates against these ridges. Kinetic energy transforms into electrical voltage. The music is not processed, it is felt. This organic contact creates the signature warm tone that digital formats cannot replicate. The market response is absolute. In the United States alone, annual sales have surged past 40 million units. For the first time in decades, heavy plastic discs are outselling compact discs. But engraving a thunderous live performance into a physical surface requires a manufacturing tolerance measured in atoms. Precision manufacturing collides with the chaotic physics of low-end frequencies. The source material arrives from the studio as a pristine digital file, typically 24-bit at 96 kHz. On a hard drive, this data is limitless, but transferring that raw energy directly onto a lacquer disc is a physical impossibility. A heavy baseline below 40 Hz acts as a mechanical wrecking ball. To replicate a loud, low-frequency wave, the cutting stylus must swing widely to carve the groove. If the bass is too deep, that swing becomes violent. The groove widens until it slices into the adjacent spiral, destroying the protective wall of vinyl between the tracks. The result is catastrophic failure. The playback needle hits this widened, chaotic trench. It vibrates uncontrollably. Unable to track the curve, the stylus is ejected from the groove and skips across the record surface. Why does the very energy that makes a track powerful threaten to destroy the disc? To prevent the needle from jumping, engineers must tame the physics. They collapse the stereo low end into a single, focused mono signal. This restricts the cutter's lateral movement, keeping the groove centered and stable. The high-pass filter engages, severing the deep subfrequencies to prepare the wave for physical inscription. Taming the sub-bass prevents the needle from jumping, but the physical space on the lacquer is still finite. To fit the full spectrum of sound onto plastic, engineers apply a global mathematical filter known as the RIAA curve. They deliberately weaken the remaining low frequencies and aggressively boost the highs before the cut. On the master tape, the audio sounds thin, weak. It is a necessary illusion. The amplifier in your living room reverses this equation instantly, expanding the bass back to its original power while simultaneously crushing surface noise. With the frequencies managed, the battle turns to geometry. A standard 12-inch platter rotates at 33 1/3 revolutions per minute. Amplitude equals width. Loud dynamic music requires wide grooves that consume surface area rapidly. If an artist demands a longer runtime, the engineer must narrow the track, forcing the grooves closer together. The volume drops, the noise floor rises. Quality trades blows with quantity. For uncompromising audio fidelity, the physical limit per side is just 22 minutes. The mathematics of the curve are set. Now, theory strikes reality. We stand at the cutting lathe. A heavy aluminum disc coated in a layer of soft nitrocellulose lacquer begins to spin. 33 1/3 revolutions per minute. The cutting head lowers. At its tip sits a hyper-sharp sapphire or diamond stylus, heated by a coil to slice through the material like a hot knife through butter. This is the point of contact. The stylus vibrates in sympathy with the electronic signal. It carves a continuous spiral from the outer edge toward the center, physically engraving the sound wave into the plastic. A thin black thread of waste material, the chip, curls off the blade. A suction tube vacuums it away instantly. If that thread drops back onto the surface, the recording is ruined. The scale is microscopic. The width of the groove is barely equal to a human hair. The machine's computer scans the audio ahead of the cutter. A heavy bass note approaches. The system widens the gap between grooves to accommodate the violent swing of the needle. A quiet passage follows. The grooves tighten up to conserve real estate on the disc. When the stylus lifts, we are left with the lacquer master. It is the first physical incarnation of the music, but the surface is terrifyingly soft. One accidental touch would wipe out the frequencies forever. Silence falls over the machine. We leave the quiet mastering studio behind. The diamond has done its job, but this fresh lacquer disc is a technological dead end. It holds the music, but it is soft, vulnerable, and chemically inert. To mass-produce sound, we must turn this plastic insulator into a metal conductor. First, a high-pressure rinse with deionized water strips away microscopic dust and oils. Cleanliness is absolute. Then comes the chemistry. The disc spins in a silvering chamber. Twin nozzles hiss as they atomize liquid over the surface. One shoots silver nitrate, the other releases a reducing agent. When the two mists collide in midair, a violent reduction reaction occurs instantly. The transformation is visible to the naked eye. The deep black lacquer vanishes. In seconds, it is replaced by a brilliant, flawless mirror. This is not a coating like paint, it is a molecular skin. The silver layer is only a few dozen nanometers thick, thinner than a patch of condensation on a cold window. It must hug the walls of audio grooves that are merely 1 or 2 microns deep. Any thicker and the delicate high frequencies would be buried under the metal. The surface is now an electrically conductive cathode ready for the tank. Silver gave conductivity, but it is too soft. We need armor. The disc submerges into a bath of emerald green nickel sulfate. Current flows and chemistry takes over. Nickel ions migrate to the surface, locking onto the silver one atom at a time. This is not a quick dip. It is a slow, calculated migration. Hours pass inside the tank. The metal skin thickens to between 300 and 400 microns. That is roughly the width of a heavy business card. When this plate is peeled away, the original lacquer is often destroyed in the process. The music now survives only on this single nickel plate known as the metal father. It is a negative image, featuring ridges instead of grooves. Using this unique master to press records directly would be industrial suicide. One scratch, one error in the press, and the album is lost forever. To protect the source, the father goes back into the tank to grow a metal mother. She is a positive copy. You could actually play her on a turntable. The mother never touches the press. She serves as a safe template to grow the final generation. The stamper. This is the expendable workhorse. The new stamper is peeled off the mother. Its jagged edges are sheared away, and the center hole is punched for the machine. While the metal cools in the electroplating shop, in the neighboring room, the body of the future record is being prepared. It begins as a cascade of raw polyvinyl chloride pellets rattling into a hopper. Small, hard, colorless. To survive the needle, this plastic needs armor. Engineers introduce carbon black. This fine powder is responsible for the iconic look, but the darkness is just a side effect. Black is an engineering necessity. Without it, the plastic would be a magnet for static electricity, attracting dust that ruins the sound. Carbon black turns the disc into a semi-conductive shield, draining the charge and reinforcing the mechanical strength of the grooves. Inside the extruder, the cold pellets face a brutal transformation. A rotating screw drives the mixture forward, crushing and melting the solid grains into a thick black paste. The texture resembles heavy dough or volcanic mud. The screw squeezes out every microscopic air bubble. One pocket of trapped air means a permanent pop in the audio track. The machine eventually spits out a soft, round mass known as the vinyl biscuit. It weighs 180 grams, roughly the same heft as a standard smartphone. But unlike a phone, this object is soft, malleable, and scorching to the touch. The chemical mixture pulses at 300 degrees. The hot puck is just raw material. It needs a form, and it needs a name. Inside the press, 2 nickel stampers wait like the jaws of a trap. Side A above, side B below. But before the plastic enters, the operator places the labels. This paper is specially engineered for survival. Touch it and it feels bone dry. There is no glue, no adhesive backing. This creates an engineering paradox. How does a thin sheet of wood pulp survive inside a machine hot enough to liquefy plastic? The label is threaded onto a steel center pin to ensure 0 deviation in alignment. When the press closes, the paper will not be pasted onto the record. It will be mechanically locked into the cooling vinyl structure. It fuses. The paper becomes the plastic. The biscuit sits on the bottom label. The top stamper hovers inches above. Everything is in place. And those 100 tons do not arrive gently. The hydraulic press engages with a mechanical roar, driving the stampers together with the weight of a mature blue whale concentrated onto a 12-inch circle. Simultaneously, superheated steam blasts through the mold's internal channels. The steel heats to 300 degrees Fahrenheit instantly. Under this combination of crushing weight and searing heat, the vinyl puck surrenders its structure. It liquefies, flowing outward like lava to fill the mold cavity. The material is forced into ridges and valleys, measuring measuring just 1 to 2 microns in depth. That is significantly thinner than a single strand of human hair. This is the industrial paradox. The world's most delicate musical nuances are forged by brute, violent force. The transformation must be locked in immediately. The steam cuts off, replaced by a surge of ice-cold water that shock freezes the plastic in seconds. The hydraulics release their grip, and the machine opens to reveal a solid, steaming disc, ringed by a jagged halo of excess material. Put straight out of the press, the record looks messy. A jagged ring of excess plastic protrudes from the rim like a scar. It is ragged, unusable. The disc transfers instantly to a trimming station where a high-speed rotating blade engages the material. In a fraction of a second, it shears the perimeter to a perfect circle. This cut creates one of 3 universal standards: 12 inches, 10 inches, or 7. The machine rounds the fresh edge, ensuring the sharp plastic won't slice through a paper sleeve or a customer's hand. The trimmed offcuts fall away, but they do not become trash. Factories collect every scrap to grind back into raw pellets for the next batch. Zero waste. Now the disc must rest. Machines stack the records on metal spindles, spacing them apart to let air circulate and dissipate the remaining heat. The polymer chains lock into their final configuration. The plastic sets in silence. When the vinyl has finally cooled, the hunt for errors begins. Under unforgiving industrial lights, a technician tilts the black disc, searching for the glint of a flaw. They are looking for enemies often invisible to the casual eye: a trapped air bubble, a slight warp in the surface, a single speck of dust fused into the plastic grooves. One defect condemns the record to the grinder. Zero tolerance. But visuals are not enough. Does the pressed copy actually sound like the master tape? To answer this, a sample disc is mounted on a calibrated reference turntable. The diamond stylus lowers into the micro grooves. The engineer listens intently for surface noise, distortion, or skipping that signals a pressing failure. Only the flawless proceed. The record slides into an anti-static inner sleeve, moving without friction against the delicate surface. This protective layer enters the printed cardboard jacket. A final tunnel of heat shrinks the plastic wrap tight around the cover. The heavy shipping box is taped shut. Now it is not just a piece of plastic, but a finished album. The journey from silence to sound is a marvel of transformation. It began as an invisible frequency in a studio, captured and optimized for mechanical playback. A sapphire stylus carved that ghost into physical lacquer. Silver and nickel baths hardened the groove into a metal stamper. Finally, steam and 100 tons of pressure forced hot polyvinyl chloride to memorize the music. The transformation is absolute. Pallets are loaded onto trucks and cargo jets for global distribution. 41 million records traverse the planet every year, outselling CDs and defying the digital age. The needle drops and the analog cycle creates sound once more.